Fine, good morning. So today let us continue with the object-oriented programming features. So yesterday I gave you an introduction about what is object-oriented programming, uh, what is a class, what is an object. Then we have discussed about the few terms which are related to object-oriented programming. That is, what is data abstraction. Uh, then we have discussed what is an attribute or a property, or then as a function or a method. Today we will especially talk about the mm, features of object-oriented programming, the main pillars of object-oriented programming, which are very necessary to understand. Mm, Now, again, if I repeat what we have just discussed yesterday, object-oriented programming is the process of analyzing and designing an application in terms of entities and objects. So, objects resemble to the real world. Okay, so that is means the applications are designed in such a way that it replicates the human thought as closely as possible. As we see the uh, um, objects around us, thinking about that, if we design an application, if we design an object, then what happens here is they will interact with each other, and the work will be done. Okay, so we discussed about an object also yesterday, that it is an anything which has well-defined boundaries that is relevant to a problem. Means any object which you are taking will have a well-defined boundaries. Uh, Means what it is doing, what it is meant for, why it has been designed. We will actually identify an object which is relevant to a problem, and we are going to use it. I hope my screen is visible to you. Okay,
Yes, sir.
no?
Yes, sir.
Okay.
Yes, sir.
Okay, thank you. Now, these objects helps us to understand the real world and provide practical basis for a computer application. So each the objects will help us to understand the real world problem and provide a practical basis for a computer application. So whatever you are developing here, uh, um, whatever you are developing. Um, mm, they provide you a practical basis. These objects will provide you a practical basis where an application works as it is resolving to a real world problem. See, a simple example I will give you, that when if you go to a bank today, you are having a banking software there. So you're using a banking software. In that, if we talk about in terms of object-oriented programming, there actually we have a customer, we can consider it as an object, a teller or a clerk, a cashier is an object. There one object is going to interact with another object, and the thing is in done. Earlier, see, if when there are no computers, we as an object will approach a bank, we will go to a teller there, we'll fill a form and we'll give it. He will process the entire things, and if you want to debit or credit an amount from your account, as per the money which you have requested, if it is there, if there is possibility, the teller is going to dispatch the amount to you. Now the same thing is being done by the computer application. Here also you'll be considered as an object. One object is going to interact with another object there. So the software where you're opening your account, you're providing your authenticity, you're providing your authentic details there. Then you are asking to transfer the amount from one account to another amount in online. So as per the application is actually transferring the amount from one customer account to another customer account. So these all things means, if you take one customer as an object, another customer as an object, so from one account to another account, the amount is being transferred. So as real world problems will work, as we see real world objects, how they are going to work, in the same way we are going to develop the computer application. So as we discussed yesterday, that each and every object will have some properties and actions it is going to perform. So any object which is actually we are developing will have certain properties and certain actions it is going to perform. So as I told you, when we discussed about the data abstraction, you will examine all the available information about an entity or an object, then identify the information which is relevant to an application. So what is relevant to an application? Our application which you are developing, we are going to consider that we are going to take only those details, and then we are going to use those details in our application. As I gave you an example yesterday, that if you are going to a bank, the bank will collect necessary information from the customer. The customer details have been entered. Then, uh, uh, then whatever the task which you have went, it is been processed. The same object, if he is going to a railway station, then that object will be called as a passenger, and there whatever the details which are required at that place are collected. Though same details are there at both the ways. I mean to say that, for example, in the bank, they are going to collect the collect the date of birth, they are going to collect the address, they are going to ask about the nominee, they are going to ask about any other details also. But when you are going to a railway station to book a ticket there, they will simply ask about who are traveling, what is their age, then a simple address, then the job is done. Okay. Likewise, so whatever the relevant information is required, you are going to gather. The relevant properties which are required, those are been identified of an object, and those are used in designing an application or building up an application. And also the actions which they are going to perform, whatever the actions the object is going to perform, those are also been identified and they are being used. The next today, as we have to discuss about, we have to understand about the features of object-oriented programming. So, the object-oriented programming languages, any language, any object-oriented programming language. See, we have Smalltalk, we have C++, we have Java, we have other modern languages like Python. These all are actually built upon this object-oriented programming. Okay, so these all features. So whatever we are talking about now, and encapsulation, the inheritance, and the polymorphism. So these are actually in all the languages there. So the main features of object-oriented, these are the very three main features of object-oriented programming: the encapsulation, inheritance, and polymorphism. So because we will talk in respect of Java later on, I just So first of all, encapsulation, if you take and encapsulate or binds the code and data together into a single indivisible unit called object. So here it binds the or encapsulate the code and the data the code manipulates. Means it is going to combine both the code as well as data at one place. Means you're going to provide the data at the same time. What means what code is operated on the data that also been provided, and it is going to bind, and it does not allow the data to be accessed from outside. So that is one of the feature of the encapsulation. It doesn't allow the data to access from outside there. It is binded inside. The code is actually manipulates and means in case of object oriented programming, there won't be any free flow of data. Data can't be flown freely. Means means one simple example I will give you that when we discussed about the global and local variables in C, there we mentioned that if a variable is declared as a global variable, it can be accessed by anyone, any function, because the global variables are declared outside the function. Any function can access the global variable. This we have discussed earlier. Now here the concept of global variables, because everybody can access the global data. Now what happens here is the data is accessed by only the code which it can manipulate, and it cannot be accessed from outside. Means there won't be much concept of global here. So you're going to provide the permission, and only those objects which are permitted to access that data can uh, uh, access the data, can use the data to perform some task there. So it increases the control of each object is it increases the control as each object is independent. Data of an object is manipulated only by the code that is a part of it. So it increases control, means you have control over the data, because data can be accessed by only that object which has the can be manipulated by only the code that is a part of the object. Means whatever the code which you are writing for that particular uh, uh, on that particular data, actually that object can access that data here. Now it allows programs to be divided into self-contained objects. It means it is allowing you to allows the program to divide it into self-contained objects. So different objects are there. Okay, now what actually practical examples I would like to give one or two in case of encapsulation to understand you very clearly. Now, I hope some of you might be holding a pen in your hand, and you are noting down some points which are been shown here. If anybody is noting down, so just think about your pen there. So when your pen is there, so you are just using that pen and you are writing it on the white paper, and it is written. But you never try to examine or never try to thought how actually the ink is filled inside that refill, how the ink is flown to the nib, how it is coming out, what type, how it is made. That is irrelevant to us. So we cannot access it from outside. Somebody has designed it, and simply we are using it. That's it. So the job is done. The same way, another very good example to understand in case of encapsulation is see, you're driving a vehicle there. So when you want to drive a vehicle, you will just what you are going to do, to drive a vehicle, you need to have enough oil in that, the petrol. So you are filling the petrol, just you are starting your bike or your scooter. Okay, so once it is started, you're giving an accelerator and it is moving. Now you never thought, I hope most of you might have never thought about how the petrol is flowed to the engine, to which part the petrol, each drop of petrol is going, uh, to which parts it is going, how the petrol is transferred from one part to another part. We never thought about this. Simply we are giving the accelerator there and the bike is moving there. That's what you are hiding all the features from outside, and you are only allowing only few features which can be accessed from outside. Okay, likewise you're taking a capsule. Oh, you're taking a capsule. So when you want to take a medicine, so when you are sick, or when you have to take a medicine, when you go to a doctor, he is writing some capsule there. So he will take he will tell you that this capsule you have to take morning one and evening one. Simply you are swallowing the capsule there. You never thought about what is inside the capsule, what type of powder it is, how it is made. You might have some out of curiosity. You might have opened that capsule, and the powder might have fall down, and it is been wasted. So we are not bothered about what is inside the capsule, how it is filled, what type of content it is. You are just bothered about, you are just swallowing it, and that's it. Whether your health, means your problem has been rectified or not. The same way here also, you're just binding the code and data together. It means here, if I say the code, if I talk about the bike, the code is your engine and your data is the petrol. You're just giving the petrol, and your code is working on that. Your code is working on that. As you're giving the accelerator, your code started working and it is moving. Means you are executing, you are running your bike there. Once you give the accelerator, the petrol is taken by the engine and it is running. So what happened to the petrol, where it is moving, how it is been transferring to the engine, to which parts it is been moving. These are not actually been thought by means that's not our problem. And in the same time, if you go to a mechanic when you got a problem, he has a knowledge about that. So he has the knowledge about. He will open all the parts. He will repair it again. He will reassemble everything, and simply he will hand over your bike to it. So that's what the encapsulation here is. You're just binding the code and the data together to manipulate, and it doesn't allow to be accessed from outside. So simply you are just allowed, or means only few features have been exposed from outside, and the other all features have been hidden there. Okay, only the few features which are necessary for the outsider citizen. So again, practically, if I might have been the physical class, I might have ask you one question. So this question, I hope, if you remember, I just asked you in the first class of C, first or second class of add two numbers. So when I say add two numbers, someone said, what are those two numbers? Then I said 5 and 4. Then you gave an answer 9. Now I know if I compare this example to this encapsulation. No, I'm just asking you add 5 and 4. You are giving 9. Okay, how you have added, how you have made the addition, it is hidden. That's what I'm talking about. So in what logic you are using to add those two numbers, it has been hidden. Whether you're using fingers, whether you are adding them on in your mind, whether you are writing it on the paper, or some other you are asking to some other people, this all been hidden from outside. Only you are providing the data, and data is being manipulated by the code, and the result is given. That's what is about the encapsulation. So you need to have an means you are going to design an application where you are going to expose only few things, and some of the things have been hidden. So that's the topic, means that is about the encapsulation. Then we have to talk about the inheritance. Inheritance allows a class to be created from another class, thereby inheriting all the properties of another class. So here you are going to create something. You are going to create something. Let us put aside about the class there. Just let us talk about something. So as means an object is created by inheriting the properties of an existing object, okay, and creating a new object. So it allows the reusability of existing classes. It allows the reusability of existing class. Means already something has been designed, and now what you are going to do here is you are going to design a new application or a new thing by inheriting all the existing properties and adding some new features to that. Now for this also you have a number of examples around you, if you can see. Now for instance, if you take your mobile, so when your mobiles have been invented, when you first got one mobile, so if I talk about India, so I saw the mobile around 1996 or 97, when the mobiles have been introduced in India. So at that time we have just a feature mobile where you can send and receive the messages, uh, you can store the contacts, you can send and receive the messages, and that's it. These are three main features there. Later on, what happens is by day, the mobiles have been transformed. In the sense, we have the mono screen, only black and white mono screen earlier. Later on, they have been changed to the color screen. Then later on, somewhat the keypad has been increased. Earlier, we just used to have the keypad of 1 2 3 4 5 6 7 8 9 and 0 and two other buttons. But now the QWERTY keypad has been introduced to the BlackBerry mobiles, where you can type the contents. And then later on, the smartphones have come, and day by day, if you're observing that, the things have been changed. So what I just want to say here is, if you consider the series of changes in the mobile history, see some features, the day one which it is providing, also it is been provided today also. So the first phone, as I said, it is used to make the calls and receive the calls. Today also we can use our mobiles to make and receive the calls. And in the day one, it is used to store the contacts. Today also it is used to store the contacts. Okay, so day one, the changes here is, in day one we can use to have can store about 200 or 250 contacts. Say today you can store about more number of contacts. There is no limit. Some of the phones I have observed, they are having thousands of contacts which are stored in the phone. And also we used to send and receive the messages. Today also we can use to send and receive the messages. So what I meant to see here is meant to say here is, you are having the existing objects, you are inheriting, you are taking all the existing properties or functions of an existing object, you are adding some new features to it, and you are inventing, you are releasing new things in the market there. And if suppose new classes may have new members and override existing members in the inheriting members. Means if some features are not up to the mark in the older ones, what you can do is you can remove them and you can add the new features, or you can override them, performing new type of task. So, new way. See here again. I just give you an example there. See what you are doing here. Here overriding in the sense, the day when when you went to LKG or UKG in the earlier classes, again if you take the addition of two numbers, you write the number of lines on the paper. If two means, if you want to add a 2 and 3, what you used to do, 2 means 2 lines you used to write, 3 means 3 lines you are used to write. Then you start counting those lines, and that is your answer. Later on, what our teachers have done, they have overridden this logic. How they have overridden this logic in your minds? They ask you to take 2 fingers in one hand, 3 fingers in another hand. Then they used to ask you to count how many fingers are there. Okay, so that's it, overridden. In the next stage, only one number is used to put in the mind, 2 in the mind, and 3 take 3 fingers, and then after 2, 3, 4, 5. Likewise, then later on, some more advanced logic. And today, if I ask you to add numbers, so you have logic. Somebody may add the numbers if any big numbers are given, because you have some this abacus. Somebody are learning today, just moving their hands itself, they are going to give the answer about how to add the numbers. So these all are actually changes which have been made there. So inheritance, as I told you, that it is going to derive the new classes, build up the new classes, and apart from having the by taking the properties of old classes. So another practical example, if you say that in your family itself, see the Almighty, when it is creating, when He is giving the child to a parent there, so some of the features, some of the properties of the parents are acquired. See, when you see, or when I see you and your parents, I can say that she looks like her father, or she looks like her mother, he looks like his father, he looks like his mother, or I can compare it like that. What is that? That is what is inheritance. You are taking the features of the existing members there, and you are having some own new features. Likewise, some of the habits of your parents you are inheriting. You are taking the habits of your parents, you are inheriting, and apart from that, you are having some new properties, new behaviors there. So inheritance is also possible in case of this programming languages. So what inheritance is doing here? See, when you want to develop a new application, you need not write the code right from the scratch. Means you need not write the code for all again thousands of lines of code. You need not write. What you simply can do is, already the existing code, you can inherit it, you can take them, and you can add the new features, and you can simply build up the applications there. So this is the concept of reusability. You are just reusing the existing classes, you are reusing the existing code, and then you are going to build up the application. Okay, so that is about the inheritance. Then we need to talk about the polymorphism. What is this polymorphism? Allows multiple methods performing same operations to have the same name. Okay, so allows the multiple methods performing same operations to have the same name. Means the name will be same, but the operations, maybe multiple methods will be there performing same operations to have the same name. Means same type of operation, if it is been performed, okay, so same type of operation is being performed, it has the same name, but it invokes, it performs as per the situation there. Okay, So here the advantage of this is you need not remember multiple names. You can simply remember one name. Uh, you can simply remember one name. Using that one name itself, then you are going to access those, invoke the methods. Depending upon the situation, the respective method is called. Now, for example, mm, I will give you a practical example here, according to you itself. Means by taking. So, see, when you are at your parents, say example, Nadeem. Okay, Nadeem. When Nadeem is at his parents, so he will he will act as a son to his parents. So when he goes to his wife, he acts as a husband. When he goes to his son or and daughter, he will act as a father. Okay, when he go to outside, he will act to the people as a friend. Okay, when he comes to the college, to his colleague, to his working people, he will act as a colleague. When he comes to the students, he acts as a teacher or a lecturer. Okay, there also means in all these cases, I will be called as Nadim only. The name is same, but what is actually changing according to the situation, according to the case, it is been changing. So the likewise same way in the polymorphism also we have the same name, but it is going to act, the multiple methods are going to act depending upon the context. What is the context? For example, I want to add two numbers. So if I want to add two numbers, say if I want to add two numbers, I I have a method called add, so which takes two numbers, two integers, and it is going to perform an operation. Next, I am going to use the same name because though different names, where I am going to pass three integers to them to add three numbers. Then I have another method which is going to take two double numbers, double type of data to perform the operation. Now, so for instance, so if I say what is 1 comma 2 comma 1 comma 1 comma 3, but okay, 13, sorry, which version will be called? The second version will be called. Okay, then if I say add 2.3 comma 4.5, okay, 4.5 for example, the third version will be called. Okay, then if I say add some 9 comma 8, the first version is called. So what is the difference here? Or what actually in all the cases you have just calling it the function as add only. What you are differing, where you are differing, you are just differing at the number of arguments or the type of arguments which you are passing to the method there. So if you are passing two double numbers, the third version is called. If you are passing two integer numbers, the first version is called. If you are passing the three integer numbers, the second version is called. So name is same, but as per the situation, it is going to differ. That's what is the polymorphism here. Name will be same, but it invokes one of the multiple methods depending upon the context. So whatever the context means here, the context in the sense what type of data you are passing, whether you are passing two integers, whether you are passing three integers, whether you are passing double numbers, depending upon that, it is going to react. Okay, so these are the three important features of object-oriented programming. So which you need to have a clear idea, because when we develop the applications, when we start writing the programs, we will be coming across these various terms. We will be talking about what is a class, what is an object, what is a method, what is an instance variable. See here, class description of collection of similar objects is called as a class. What terminology we are going to use? Class, the description of collection of similar objects is called as a class. Class defines the data members and methods to be encapsulated. Methods are defined within the class here. So we will talk about this later on. But what is a class? It is a description of collection of similar objects. So as I told you here yesterday that a class is a collection of similar objects. Now yours is a class. So all the members here, say, if I just show you here on the screen, uh, um, so this is a class. Okay, I hope you can see your names. Sorry, one thing. One second. Yeah. No, beside this, all the names have been displayed here. It is a collection of classes. It means why you all are came here, why you all have logged in, because you belong to the same class. You have the similar objects here. A class is a collection of similar objects. Okay, so it defines the members. So what members it should have, means what properties the class member should have, and what actions they should perform will be told. Okay, then you have an object which is an instance of a class. An object is an instance of a class. Memory is allocated only when the object of this class is created. Okay, an object is an instance class. See, I say MCA second semester. No, it is a class. MCA second semester is a class. Uh, uh, when the class actually gets a shape, when that class is having some physical appearance, only when the students appear in the class. If no student appears in the class, if no student is attending the class, when no students has a is present in the class, that class doesn't have any meaning. So a class is actually a logical entity, an object. The instance of the class is a physical entity. So that's why presence of a student, physically the presence of a student is actually important. So that's why I call the students here as an object here. You're the instance of class MCA second semester. Okay, so you when you have the instant means the properties and also the actions which you can perform there. Okay, so as I told you, the methods, it is a function defined within the class. It is used to process the data of the class. Okay, and only the methods are generally callable from outside. These all things we will discuss later on. So we have an instance variables, the properties. The instance variables generally called as an properties which are associated with an objects, and we have the methods which are actually the functions which the class can perform. So that's about the features of object-oriented programming. Okay, so next class we will today I don't want to start and leave it in the middle. So in the next class I will introduce you what is Java. Okay, so how it came into existence, what are the relationship between C++ and Java, and then you have the features of Java which we need to discuss very elaborately. So these all things will be discussed in the next class. So yesterday I have shared with you three contents, two textbooks I have shared, and also the notes which I have generally prepared, which I am referring now. All these three things have been shared. So Herbert Schultz's book is very good book for beginners, and there I have I think I have shared another book there. Just let me check. Yes, the complete reference, and also the another introduction to Java I have shared with you yesterday. Okay, so that book also contains a lot of examples. Introduction to Java contains a lot of examples. You can refer to examples in that for your practice. But to generally learn the concepts, the Herbert Schultz book is very good. You can use it. Okay, so any doubts from your side today?
No, sir.
No, sir.
No, sir.